One and all. Today, we are going to see a problem on load curve, load duration curve, load factor, reserve capacity, plant use factor, and plant utilization factor. Take down this problem. A generating station of 1 megawatt supplied a region which has the following limits. Neglect transmission line losses and find the following. So the load they have given and also time they have given from midnight 12:01, actually midnight 12:01 a.m. and 12 a.m. that is mentioned to 5 a.m. that is 100 kilowatt, and 5 a.m. to 6 p.m. no load, 6 p.m. to 7 p.m. 800 kilowatt, 7 p.m. to 9 p.m. 900 kilowatt, 9 p.m. to midnight it is 400 kilowatt. Usually like this kind, say for example 5 a.m. morning 5 a.m. to 6 p.m. there is no load. So I think there is a major fault happens, or otherwise that area might be went for some maintenance, okay, from 5 o'clock to 6 p.m. or otherwise some fault, okay, some major fault happened in that particular time. For clearing that fault, it taken some time, but usually it will be not like this. But they just like that they frame the question like this. So now we need to plot the daily load curve and the load duration curve. Next, to find the load factor, reserve capacity, plant use factor, and hours that the plant has been off, and utilization factor. They need to we need to solve. We need to find it. First, load curve. Load curve, as I said, say for these loads, you need to draw the load. Say, for example, the load curve we have drawn. I'm saying like in the this axis. This axis is the time axis, time hours we are taking. So generally, you take if you take your scale and mark 1 centimeters, but the scale you draw mark it as 2, 4, 6, 8, 10, 12 p.m. to 2 p.m., 4 p.m., 6 p.m., 8 p.m., 10 p.m. and 12 midnight. Like that, you just take. So I'm taking this two scales here in the time scale usually. Next, we are taking the load in kilowatt, because in the problem it is given in kilowatt, load in kilowatt. Based on the problem, as I said, based on the problem, you need to choose the scale. I have taken here as 100, 200, 300, 400, 500, 600, 700, 800, and 900. Say, for example, here in this load curve, for 12 a.m. to this 5 a.m., 12 a.m. to. So in this load duration curve from 12 a.m. to 5 a.m. that is 100 kilowatt, and after 5 a.m. there is no load. Up to 6 p.m. there is no load. Again, the load is raised to some 800 kilowatt. After that, up to 9 p.m. After 9 p.m. sorry, up to 7 p.m. From 7 p.m. again it raised to 900 kilowatt, and again it is decreased to 400 kilowatt from 9 p.m. to 12 midnight. So this is how the problem is given. Based on that, we have drawn the load curve. Next, we need to draw the load duration curve. As I said, in the load duration curve, first you need to draw this load and also duration. First, you need to draw, and we need to sort the data. Whatever the data given in the problem, we need to sort in the descending order from higher to lower. Say, for example, 900 kilowatt, 800 kilowatt, 400 kilowatt, 100 kilowatt, and 0. Okay, 0 means no load. And duration also it is happening. Duration first. So for example, 900 kilowatt, what is the duration? Say, for example, if you go here, yeah, 900 kilowatt duration is 7 p.m. to 9 p.m. 2 hours. Next, 800 kilowatt, 6 p.m. to 7 p.m. 1 hour. Next is 400 kilowatt, 9 p.m. to 12 a.m. So 9 p.m. to 12, 10, 11, and 12, 3 hours. Next 100 kilowatt for from 12, 1, 2, 3, 4, 5. So 5 hours. Next, this 5 a.m. to 6 p.m. no load. So 0 kilowatt. That is for 5 a.m. to 6 p.m. 13 hours. So like that, first you need to draw. First you need to write all the loads in this descending order, and you need to write the duration. Say for example, 900 kilowatts for 2 hours. Next 800 kilowatt for 1 hour. So 2 plus 1 is 3. So here we are writing in duration. So 2 plus 1 is 3. Similarly, 400 kilowatt for again 3 hours. So 3 plus 3 is 6. Next again 100 kilowatt for 11 hours. 100 kilowatt for 11 hours. So 6 plus 5 is 100 kilowatt for 11 hours. So 100 kilowatt for 5 years. So 6 plus 5 is 11. So 11 hours duration. Next no load for 13 hours. So 11 plus 13 is 24. So here in duration, at last you need to get 24. That is the thing. So if 24 hours will be coming, means your problem is correct. If anything you made a mistake, if it is given, the load is given for per day data, then it needs to come 24. If it is given for some years and all, so that 365 days, whatever the years, say for example, 5 years, or 2 years, 3 years, like that given. So that particular years will come. So here it is a whole day given. So here 24 hours in a day should come. The duration at last you should get 24. If say for example 23 is coming or 25 is coming, you made a mistake in between. So you need to check the duration correctly. Next, so this is how you need to mark the duration, and from this duration easily you can draw the load duration curve. Yeah, load duration curve is very simple. So in this axis, we are taking this duration in hours. So here you need to write duration load while drawing the load duration curve. So you need to write like duration in hours. So duration curves here also I have taken as 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24, because it is duration. No, that's why I have directly taken in all 0, 2 like that up to 24. Say, for example, in the previous load curve, we have taken as from 12 midnight to 12 p.m. Again 12 p.m. to again 12 midnight, like that we have taken. But here it is in duration that you need to remember. Next load. So first what 900 kilowatt. 900 kilowatt for how much duration means 2 hours. So again 800 kilowatt for 1 hour. 800 kilowatt for 1 hour, and next 400 kilowatt for again 3 hours. 3 hours. So it comes to up to 6 hours. Next 6 to 8. Okay. Load durations 100 kilowatt for 6 to 11. Okay, 6 to 11. So 6 to 11 is 5 hours. Next after that 0. From 11 hours to 24 hours 0. So that's how, from 11 hours to 24, it is 0 kilowatts. So like that, based on this data, we need to draw the load duration curve. So this is how you need to draw the load duration. Next, we need to find out what are the things asked. First, they asked the plant load factor. So plant load factor is equal to average demand divided by maximum demand. Maximum demand is 900 kilowatt. It is clear from load duration curve. Load duration curve, what is the maximum you need to see? Yeah, this is the maximum. So this might be the maximum demand. So 900 kilowatt is the maximum demand. It is clear from the load duration curve. Next step. So plant load factor is equal to average demand divided by maximum demand. How to calculate the average demand? Average demand is equal to units generated divided by time in hours. Unit generated is equal to, so as we did it in our previous problem, just what are the data given into that duration in hours. Okay, or otherwise you can go with this also. Okay, say for example 100 kilowatt into 5 years. Next plus 400 kilowatt into 3 years plus 800 kilowatt into 1 hours. Next 900 kilowatt into 2 hours. Like that also you can add, or from the data, from the problem data. Yeah. So 100 kilowatt into this is 5 years. So 100 into 5 plus next this is no load. So here also you can write 13 into 0 plus again 6 to 7 1. So 800 into 1 plus again 900 into 2 plus 400 into 3. Like that you need to add. So unit generated you will get. Yeah, that is how we did. So unit generated we got as 4,300 kilowatt hour unit generated. So average demand is equal to 4,300 kilowatt hour divided by 24. 24 you did, you'll get 179.167 kilowatt. Next, what is plant load factor? Average demand divided by maximum demand. Average demand, whatever we got the data, divided by maximum demand, that is 900 kilowatt. So if you solve into 100, because load factor, plant load factor in percentage, so into 100, you'll get 19.9 percentage. Next, you need to calculate plant capacity factor. How to calculate the plant capacity factor? Plant capacity factor is equal to total energy generated. Total energy generated divided by capacity of the plant into number of hours. So total energy generated, how to calculate? Already we calculated capacity of the plant, how to do the capacity of the plant. That is 1 megawatt given in the problem. Capacity of the plant is 1 megawatt. Yeah, if you go through the problem, you may easily get a generating station of 1 megawatt supplied a region which has a following demand. So 1 megawatt is the capacity, plant capacity. So that is given in the problem. So here simply you can write that 1 megawatt. So capacity of the plant is 1 megawatt. But here all are, we are dealing with kilowatt. So we are converting this megawatt into kilowatt. So what we need to do, it is 1000 kilowatt, 1000 kilowatt. So plant capacity factor is equal to this unit generated divided by capacity of the plant, that is 1000 into number of operating hours 24. So into 100, because in percentage, if you simplify, you'll get 17.91 percentage. Next, plant use factor. Plant use factor is equal to total energy generated divided by rated capacity of the plant into number of operating hours. So total energy generated, already we calculated. Here, rated capacity of the plant we need to calculate. Rated capacity of the plant into number of operating hours. So rated capacity of the plant, how to calculate? Now, here, while drawing this load duration curve, you drawn one table, no? Here itself you can do. Say, for example, for generating a 900 kilowatt, you have because 900 kilowatt generators not available, because generator size available is 100 kilowatt, like a 500 kilowatt or 1000 kilowatt, like that. Or in terms of megawatt, if you say 100 megawatt, 500 megawatt, 1000 megawatt, 1500 megawatt, 2000 megawatt, like that only generator size are available. So for generating this 900 kilowatt, you need 1 into 1000 kilowatt generator. And for generating 800 kilowatt also, you need 1 into 1000 kilowatt generator. Here, for generating 400 kilowatt, you need 1 into 500 kilowatt generator. For generating 100 kilowatt, you need 1 into 100 kilowatt generator, because that is the minimum size of the generator available. So if you can't generate 800 megawatt directly, because generator, based on the generator size only, you need to choose. So here, you need to be very, very careful while doing this problem by calculating the rated capacity of the plant. So rated capacity of the plant, you can do it here also, same thing, same answer will come. Or otherwise, there are also 1 into 100, so 1000. So 1 into 1000, so 1000 into 2 plus 1000 into 3, number of operating hours. Like that you need to do. Here how we did? Yeah, same thing we did. Here also, yeah. 100 into 5. So we started from that data, whatever the data given. So 100 megawatts. So we once again will go to the problem data, then you will be clear. Yeah, problem data, yeah, 100. So for generating 100 kilowatt, 1 into 100 kilowatt generator. For generating this no load, no needed. For generating 800 kilowatt, 1 into 1000 kilowatt generator. For generating one, 900 kilowatt, 1 into again 1 into 1000 kilowatt generator. For generating 400 kilowatt, 1 into 5. So 100 into number of operating hours, the duration. So 100 into 5 plus again 13 here, 5 to 6 is 13, 13 into 0 plus here um, here it is, yeah, 1000 into 1. Okay, 1000 into 1. Operating hours is 1000 into 1. Here operating hours is 2 hours. So 1000 into 2 plus next 500 into 3. Okay, 500 into 3 like that. Here, based on the operating hours you need to do. So that's what we did here. Rated capacity of the plant into number of operating hours, 100 into 5 plus 0 into 13 plus 1000 into 1 plus 1000 into 2 plus 500 into 3. So if you add all this operating hours, 24 hours should come. So 5 plus 13 is 18, 18 plus 1 is 19, 19 plus 2 is, sorry, yeah, here 18, 19, 20, 21, 22, 20, 24. Yeah, so 24, 18, 18, 19, 20, 21, 21 plus 3 is 24. So that also you have to remember, as I said before. So here, if you add all these things, you'll get 5000 kilowatt hour. So what is the plant use factor? Unit generated divided by rated capacity of the plant into number of operating hours. So unit generated already we calculated 4300 kilowatt hour divided by this rated capacity of the plant into number of operating hours also we calculated, that is 5000. So if you just divide it, simplify it, you will get the answer as 0.86 into 100 because in percentage into 100. So you will get 86%. So plant use factor is 86%. Next, they asked this number of hours that a plant is being off. So from the load duration curve or load curve, whatever. So from which operating hours the plant is being off now? I think from morning 5 a.m. to 6 p.m. 5 a.m. to, if you see the data or otherwise load curve. So morning 5 a.m. to, here this is a.m. 5 a.m. to 6 p.m. the load is being off. That is generators being off. So that is the answer. So how many hours means 13 hours. Like that you need to write. So which period the what they ask, number of hours that the plant is being off from 5 a.m. to 6 p.m. that is no load. So the number of operating hours that a plant is being off, that is for 13 hours because 5 a.m. to 6 p.m. That duration is 13 hours. So that you need to write. Next, plant utilization factor. Plant utilization factor is equal to maximum demand divided by rated capacity of the power station. Rated capacity of the plant is given as 1 megawatt. That we need to convert into kilowatt. That is 1000 kilowatt. So you just substitute here. That is maximum demand 900 kilowatt divided by rated capacity of the power station is 1000 kilowatt. So you'll get 0.9 into 100 for a factor. Okay, into 100 you need to multiply. Next, so the plant utilization factor is 90%. So this is how you need to solve the problem. So in this problem, I think almost all things we solved in one problem itself. First, we solved a load curve. First, we plotted a load curve, load duration curve. Next is we calculated load factor, plant load factor, then reserve capacity, reserve capacity, then plant capacity factor, plant use factor. Next, number of operating hours that plant is being off. Next is utilization factor. Thank you. Thank you.